Hi, IED students. We're going to watch a 9-minute video on disassembling a coffee pot. Now, we're not going to actually disassemble a coffee pot. That's why we're going to show you the video. But this is what we would do if we would actually go through and take an electronic component, like a coffee pot, dismantle it, and tell me about all the different parts on there. Okay? So here's the video that we're going to watch.
Today we are going to disassemble a Brentwood TS112R red single cup coffee maker. The purpose of our teardown is to understand a little better the functions, components, materials, fabrication, and technologies employed in the construction of the coffee maker. The first part of the coffee maker that we will take apart are the exterior elements. We will remove the ceramic mug and plastic polypropylene drip tray. The smooth, glossy ceramic mug is used to collect brewed coffee and has an inner diameter and height of about 3¼ inches. The mug sits on the bumpy surface of the drip tray and captures any overflow of coffee. Unsnap the hinge to remove the plastic lid from the red polypropylene housing. The mesh and plastic filter nest inside of the coffee and water funnel, and the two pieces sit inside the housing to receive the coffee grounds and allow the hot water to move up the silicone tube, through the shower head, and then onto and through the coffee grounds. The red housing appears to be injection molded and formed to create a water reservoir. When water is placed in the reservoir, it passes through the hole in the bottom and then comes back up, heated through the hole connected to the water tube and shower head. We will see how the water is heated soon. The brewed coffee ends up in the ceramic mug by moving through the two holes in the bottom of the coffee and water funnel. All the plastic pieces appear to be made from polypropylene, which is a low-cost plastic often used in making small kitchen appliances. As we continue to take apart the coffee maker, we will need tools such as screwdrivers and pliers. Gather all the tools needed to take the product apart. You may wish to include measurement tools such as scales and dial calipers. Turn over the coffee maker and remove the 6 screws that hold the plastic base to the 2 housing pieces. Note that there are vents in the base. These are most likely to dissipate heat as the coffee maker operates. Also, note that there are raised portions of the base to provide feet for the coffee maker to rest above the countertop. When the plastic base is removed, the heating subassembly, electrical subassembly, and water tube subassembly are revealed. Using pliers, unclip the wire terminals from the switch that provides electrical power to the coffee maker's heating element and temperature sensor when in the on position. Note that there is a direct connection between the switch and the temperature sensor using the blue wire. As the water is heated to a specific temperature, the sensor turns the circuit on and off to maintain a proper temperature for brewing. Next, unclip the wire terminals from the temperature sensor and the ends of the U-shaped heating element. Then, unscrew the 2 steel screws that are securing the cord bracket and remove the bracket from the housing. The reason why the cord is knotted behind the bracket is to prevent the cord from accidentally being pulled out of the coffee maker. This is a safety feature because any loose wires could be a potential fire hazard. All the electrical connections should be removed at this point. Remove the 2 black plastic screw covers and then use a Phillips head screwdriver to remove the 2 screws holding together the red and black housing. The red and black housing pieces can be pulled apart at this time. Let's look at how the water is heated. Remember that the bottom of the water reservoir had a hole for the water to drain. The water drains into another tube that has a small, hard ABS plastic one-way ball valve. Gravity pulls the water down through the tube and valve into the U-shaped aluminum water tube and back out and partially up the tube that connects back to the red housing. The one-way valve prevents the water from going back into the reservoir. The resistive heating element is directly below the aluminum water tube in another aluminum tube. This element heats up when electricity is supplied. Because aluminum is thermally conductive, the heat is transferred to the water. When the water boils, the bubbles rise in the water tube. The tube is small enough and the bubbles large enough to allow a column of water to ride upward on top of the water. You can see this happen if you watch the coffee maker with the lid open during operation. Remove the screw holding the heating element to the red plastic housing. A flathead screwdriver worked better to remove this screw. Note that this screw has an insulating washer to prevent the screw from conducting heat. Also, note that the bracket is insulated from the heating element by a fiberglass braided wrap. A nylon spacer also insulates the screw boss, which is a protruding piece of plastic on the inside of the plastic housing, from the heating element. We wouldn't want the plastic housing to melt during operation of the coffee maker. One important safety mechanism on the coffee maker is the temperature sensor, or thermostat. This sensor shuts down the coffee maker at a predetermined temperature. So, if the water gets too hot, it will turn off the coffee maker. And if the water is too cold, it will turn the coffee maker back on. Most likely what is inside the sensor is a bimetallic strip. One part of the strip has a low thermal expansion, while another has high thermal expansion. If too much heat is applied, the strip will bend away from the electrical contact and will stop conducting electricity. As the strip cools, it will bend back towards the contact, once again conducting electricity to the resistive heating element. The metals are chosen based on the temperature that the designers want the water to reach. Remove the aluminum bracket using pliers. There is a white, thermally conductive paste underneath the sensor when it is removed from the heating element. This helps conduct heat to the sensor. There is also paste inside the resistive heating element along with the coiled heating element itself. Another safety mechanism on the coffee maker are the thermal fuses attached to each side of the heating element. The insulating fiberglass sheathing can then be removed, as can the plastic tube protecting the thermal fuse. The fuse has an internal sensor that is preset to the highest acceptable temperature. If the heat monitored by the fuse exceeds that temperature, the fuse will blow and break the circuit, shutting down the coffee maker. Taking the clamps off the water tubes will disengage the heating element from the red plastic housing. Note that the one-way valve has a small plastic float or ball inside, which prevents the backflow of water into the reservoir. When everything is removed from the red plastic housing, you can turn it over. On the bottom of the water reservoir is a recycling symbol with the letters PP. This symbol lets you know that the housing material is polypropylene. There are 3 screw bosses at the bottom which connect the base and 3 screw bosses at the bottom of the black housing. The red and black housings snap fit together and then are screwed together through the top of the red housing. There you have it! The coffee maker is disassembled. Information recorded on the product disassembly chart includes the name of each component or major subassembly, functions of every component, materials used to create each component, weights of components, shape and dimensions with appropriate tolerances, finishes on components, and notes of interesting observations. This information can be used to create system models, including CAD assemblies, which are valuable for understanding functionality. You can then assess the suitability of the overall design based on cost, expected life, service environment, and other criteria.
So there's your video. Structural analysis of a coffee pot. Like I said, we're not going to tear apart a coffee pot, but we are going to tear apart something else.